Let's graph some lines with points. In the very first example, I've got x plus y equals 5. Now we want all of the numbers for x and y together that add up to 5. We're going to organize this into a t-table, just a really simple table that looks like a t, and let's come up with some numbers that add up to 5. Now these are pretty easy to come up with in your head. So we could do 1 and 4, and certainly 1 plus 4 is equal to 5. So I can graph that point. 1 for x and 4 for y gives me the point right here. Another great pair would be, say, 2 and 3. So that would be 2 plus 3 is equal to 5, check. And I can go ahead and graph this. 2 for x, 3 for y puts me right here. Now there are a bunch of these. 0 and 5 is another one. So 0 for x, 5 for y, those certainly add up to 5, and it gives me the point right here. Notice how these are lining up super nicely. Now we can keep on going with the points. I could swap the order and I get 5, 0. I can even use a negative and I get negative 2 and 7. There are infinitely many of these. I certainly have enough to draw my line in. Let's go ahead and graph that line, and we end up with this. Now I've got my line. It does go on forever. Every single value that this line passes through gives me another point. So for example, here's one that we didn't list. This is 4 for x and 1 for y, and certainly 4 plus 1 is equal to 5. So every single point, infinitely many points, give me solutions to this equation. In this next one, I want to find all the x's and y's that make 2x plus y equal to 4. We're going to go ahead and come up with points and organize them in a t-table, but how many points do we actually need? We really only need 2. As long as we've done them correctly, we know that they're going to line up. A third one isn't a bad idea. Now, while you're finding these points, let's make it as easy as possible. There's infinitely many, so let's pick really nice values like zeros. I'm going to start off with a 0 for x. So when x is equal to 0, I get 2 times 0 plus y equals 4. I'm going to solve this little mini equation. 2 times 0 is 0, and y is equal to 4. So I get that point 0, 4. I can do the very same thing, but this time let's let y equal 0. When I let y equal 0, I'm going to go ahead and plug this in. So I get 2 times x plus 0 equals 4. I'm going to solve this mini equation. I've got 2x is equal to 4. Divide both sides by 2, or you can do this just by looking at it, and I get for that value x is equal to 2. Now I'm ready to graph both of these. So I've got 0 for x and 4 for y. That's this point right here. My second point is 2 for x and 0 for y. That's going to be this point here. Let me grab my green pen, and I can line these two up into my line. Remember, every single point that these pass through is a solution to this equation. Now here's one with a fraction in it. Because there are infinitely many values that we can choose from, let's choose the easiest ones that make that fraction go away. So I'm looking at that 1/3 times y. A really easy place to start is by letting y equal 0. If I let y equal 0, I end up with x plus 1/3 times 0, that goes away, is equal to 5, and my x value is 5. Now, another really easy way to get rid of that fraction is to multiply it by something that we can cancel the 3 with. Let's let y be a 3. So if y is equal to 3, I get x plus 1/3 times 3, and you can think of that as a 3 over 1, is equal to 5. Now those 3's cancel, but something divided by itself is 1, so I get x plus 1 is equal to 5. If I subtract 1 from both sides, I get the x coordinate that goes along with y equals 3, and that's going to be x is equal to 4. Let's plot both of these. So I've got 5 for x and 0 for y. My second point is 4 for x and a 3 for a y, which is this point right here. And I'm going to go ahead and graph those going right through those 2 points, remembering to put an arrow on either end. You are doing so great. Next, let's take a look at these lines and their slopes. Thanks so much for watching.